Hello students. Today we are going to solve a question from molecular physics, and this question basically asked in TIFR-2022. Okay. So in that question they have given that H2 molecule can be treated as a rigid rotator. Okay. So you can think like this. You have a H atom and you have a H atom, and their bond length basically fixed. Okay, or not. So wavelength next to largest in the rotational spectrum of this molecule, that is given, that is 111 micrometer. So wavelength next to largest, please keep in mind. So from this given information we have to calculate that separation between these two atoms, or basically you have to calculate the bond length of this molecule. Okay, so we know that rotational energy of rigid rotator can be written as E as a function of J, that will be basically h cross square divided by twice I, and then you have J into J plus 1, where J is your rotational quantum number and it can take values like 0, 1, 2 and so on. Okay. Now wavelength next to largest in the rotational spectrum, what does it means? So largest wavelength will be possible when there is a transition of molecule from J equals to 1 to J equals to 0. Why? Because this separation is smallest. Okay. So next to largest means the next largest wavelength. So that means when there is a transition of molecule from J equals to 2 to J equals to 1, that will provide that wavelength that will be next to largest. So this will be the largest one and this will be the next to largest. Okay, so let us calculate this. So energy separation between these two states, 2 and 1, that will be how much? I can write like delta E, that should be equals to E2 minus E1. Okay, and if I do this, I'll get this term as a common. So it will be h cross square divided by twice I. Now in place of J you have to keep 2. Okay, for first term, so 2 into 3, that will give you 6, and if you keep J as a 1, it will give you 2. Okay, 1 into 2. So this will provide 2 h cross square by I. Nothing, just 4, and you have 2 in the denominator, so 2 will be cancelled. Okay, so this will be the separation. Now that I can write, that is nothing but hc by lambda. Okay, so it means I can calculate that value of moment of inertia, or I can write that moment of inertia, that will be how much? You have 2 h cross square divided by, also you have lambda here, divided by hc. Okay, and I is moment of inertia. I is nothing but what? I is nothing but mu into r naught square. Okay, and that should be equals to 2 h cross square lambda by hc. Okay, now what will be the value of mu? Mu is the basically reduced mass. So we know that each hydrogen atom contain only one protons. Okay, so their reduced mass will be how much? Mp into Mp divided by Mp plus Mp, that will be twice Mp. Okay, so this will be cancelled. I'll get twice, Mp by 2. Okay, okay. So it means R naught square, that should be equals to how much? R naught square should be equals to, you have to keep, in place of mu you have to keep Mp by 2. So if you keep it, you'll basically get 2 h cat square lambda into 2 divided by hc into Mp. So this 2 is basically coming from where? From this. Okay, if you keep here mu as a Mp by 2, so this 2 will go here. Okay, okay. Now I can write, in place of h cross, I can write h by 2 pi. And if I write this, I'll basically get h lambda divided by pi square. Okay, divided by pi square into C into MP. Okay. So now every value is given. H is nothing but 6 into 6.6 into 10 to the power minus 34. Lambda is given 111 micrometers, so in meter it will be 10 to the power minus 6. Okay. Pi square means 3.14 chi square. Okay. Then you have C. C is nothing but 3 into 10 to the power 8. Okay, 10 to the power 8. And then you have MP. That we know MP is nothing but 1.27. Okay, into 10 to the power minus 27 kg. Okay, so this is your R naught square. So if you calculate these values, I have calculated, you will get that R naught value, that will be 1.2 into 10 to the power minus 10 meter. So it means it will be in nanometer. I can write 1.2 nanometer. Okay. So according to that given option, okay, according to that given option, so this is not 1.27, this is basically 1.67, sorry. According to given option, option A will be the correct. So this will be the answer. Okay, thank you.